Hello my dear children. This video might be a little long because I have two difficult topics to explain to you. So just, take a deep breath, settle in, get comfy, and we're going to learn all about determinants. Alright, there is a real number that's called a determinant, and it is associated with each square matrix. So determinant is a key word here, and so is square. This is only for matrices that are square, like 2 by 2, 3 by 3, things like that. Alright, so first let me tell you how to do the determinant of a 2 by 2 matrix. Alright, so let's say we have matrix A is A, B, C, D. Then the determinant of matrix A is written like this. Straight bars, A, B, C, D. Who knew that those little hooky things were going to be so important? So when you're writing a matrix, you have to include these. When you're writing a determinant, you have to leave them off. So the determinant looks like this. It's almost like an absolute value kind of thing. And to find it, you just multiply A times D and then subtract B times C. So I like to say Chris minus cross. And that would be something that you need to have memorized. So let's do a quick example. All right, this is what I might put on the test. Just straight up 3, 5, 1, negative 2 with the bars around it, the determinant bars. And so you have to recognize what that's asking for. That is asking for the determinant, and it's going to be Chris, so 3 times negative 2, minus cross, minus 5 times 1. So that's negative 6 minus 5, and that gives you negative 11. So the determinant of that is just negative 11. It's just one single number. And that's it. That's all you have to do. Alright, now we're going to find the determinant of a 3 by 3 matrix, and we're going to use the expansion by minors method. Alright, so there's this thing called a minor, and it is associated with each element of the matrix. Remember, the elements are the pieces, and it is found by eliminating the row and column of that given element. The resulting dimensions of the minor is always going to be one less than the original matrix because you're going to be crossing out one row and one column. So a minor is going to be the determinant of what's left. So watch this. Here's a 3 by 3 matrix. If I wanted to find the minor for element A, I would cross out A's row and column, and then I would take the determinant of what's left, E, F, H, I. So I would go EI minus HF, whatever that is. And I do that for any element. So suppose I wanted the minor for F. I'd cross out F's row and column, and F's minor then would be the determinant of what's left, A, B, G, H, which would be A times H minus B times G. Alright, now each element of a matrix also has a sign associated with it based on its position. We always start with a plus in the upper left hand, and then it just alternates. So if it was a 2 by 2, it would look like that. Or if it was a 3 by 3, it would start with a plus, minus, plus, minus, plus, minus, plus, minus, plus. And keep in mind that these signs are in addition to whatever signs are with the element. So if I had a negative 5 in this spot right here, and then I applied that minus sign to it, then it would become negative 5, which is positive 5. So we have these signs to associate with each element too. So now I need to define a cofactor for you, and that consists of the product of the element, its sign, and its minor. So you'll find the minor, like I said, crossing out the row and column, and find that determinant. You will take that element and its sign and multiply those things together. So it might look something like this. So for our alphabet matrix here, if we were just going with A's minor was the determinant of E, F, H, I, and we're multiplying that by the element A and by its sign, which in this case is plus. So we do positive times A times the determinant Chris minus cross of this. Or if we were doing B, then we would have negative, and then we'd have B, and then we'd have B's minor, which in B's case would be DFGI. And so then we would have negative, and then that number, and then that number. So each element has a cofactor. Okay, so now, if you want to expand a matrix by minors, first of all, you will be told what row or column to expand by. Or if you aren't, you're going to pick one. And you're going to add up the cofactors. Remember, we just talked about cofactors of each element in that row or column to get the final determinant. So I'm just going to do a few examples so you can see how that works. Alright, we have this 3 by 3, which is a square matrix. I have the bars around it, which means I want the determinant of it. And the instructions say expand along the first row. So that means I'm going to go with this first row here. And we start with the first one, the 5. So I've got the sign of this is plus, the sign of this is minus, and the sign of this is plus. So I'm going to say plus 5 times 5's minor. When I cross out 5's row and column, I have 4 minus 1, 2, 0. Then I'm going to take the second term, minus, and then 0 times that one's minor. If I cross out that row and column, I have 1, negative 1, 3, 0. And then I have plus 2 times 2's minor, which when I cross out that row and column is 1, 4, 3, 2. So I've got 5 times, and then I'm going to take Chris minus cross is 0 minus negative 2. Then I'll have minus 0 times Chris minus cross is going to be 0 minus negative 3. Plus 2 times Chris minus cross would be 2 minus 12. So I'm going to do that math, and I'm going to have 5 times 2 minus 0 times 3 plus 2 times negative 10. 10 minus 0 plus negative 20. 10 and then minus 20 gives us a negative 10. So the determinant of this 3 by 3 matrix is negative 10. Alright, we're going to do another one. This time it says expand along the second column. So you got to make sure you know what the difference between a row and a column. Second column would be this middle column here. So I'm going to start with, and the signs on this one are minus and a plus and a minus. So I'm going to start with minus 0 times 0's minor, which when I cross out that row and column is 1, negative 1, 3, 0. Then I'll have plus 4 times 4's minor, which is 5, 2, 3, 0, 0. And then I go with minus 2 times its minor, which is 5, 2, 1, negative 1. So when I multiply that out, I have minus 0 times anything is just 0. I'm just going to write 0. Plus 4 times Chris minus cross would be 0 minus 6. Minus 2 times Chris minus cross would be negative 5 minus 2. So I have 4 times negative 6 minus 2 times negative 7. So 4 times negative 6 is negative 24. And then I'm going to end up adding 14. Negative 24 plus 14 is negative 10. Why is this the same as the one we just did? Because it's the same matrix as the one we just did. So the determinant is the same thing no matter what method you use. The determinant of this matrix is one number. It's negative 10. So now let's do one where we expand along the second row. So second row would be right here. The signs that go with this are minus, plus, minus. And note that the minus that I'm putting with this negative 1 go in addition to the negative, so it's actually going to turn into a plus 1. So I have minus 1 times the 1's minor, which is going to be 0, 2, 2, 0. I have plus 4 times the 4's minor, 5, 2, 3, 0. And then I have minus negative 1, so plus 1 times that one's minor, which is 5, 0, 3, 2. So when I do negative 1 times 0 minus 4, plus 4 times 0 minus 6, plus 1 times 10 minus 0, I get negative 1 times 4 is negative 4, plus 4 times negative 6 is minus 24, plus 1 times 10 is plus 10. 4 minus 24 negative 4 minus 24 plus 10 gives us negative 10. Aha, I knew I'd made a mistake. Negative 1 times 0 minus 4 is positive 4. That's why it equals negative 10. So sorry about the mistake. I'm not going to go back and erase it now. Too bad. But you notice it's negative 10. It's the same thing as the last two were. So hopefully now you understand expansion by minors. And now we get to do another method. Okay guys, this method is called the diagonals method, and I think you're going to like it better than the first one. However, you are going to be expected to know how to do both methods on the test. Alright, the diagonals method says, step 1, you're going to repeat the first two columns to the right of the determinant. So let me give you an example. Here's a good example. So we're going to repeat the first two columns, this one and this one. So we're just going to write 2, 4, 3 right here, and negative 1 and 1 and negative 4 right here. So you just copy down the first two columns. Then it says subtract the sum of the top products from the sum of the bottom products. And that doesn't make any sense unless you see what I'm going to do. First, I'm going to find the three Chris values. These, and these. So I'm going to multiply 2 times 1 times negative 2 gives me negative 4. Add it to negative 1 times 0 times 3 is 0. And add it to negative 3 times 4 times negative 4, which gives me 48. And so if I add those together, I get 44. So that's your Chris. And then we're going to do minus cross. So our crosses, we're going to go up so that we can write the number at the top. I'm going to go this way. And I'm going to go 3 times 1 times negative 3 is negative 9. And negative 4 times 0 times 2 is 0. And negative 2 times 4 times negative 1 is positive 8. When I add those up, I get negative 1. So I'm going to take the sum, subtract the sum of the top products, take my blue one, from the sum of the bottom products. It's just like when we do a 2 by 2 and we go Chris minus cross. I'm going to take 44 and subtract negative 1. And 44 minus negative 1 is 45. So that's your determinant. It's much faster, however it is easy to mix up. You have to make sure that you're doing the bottom sum minus the top sum. Right. So now let's do a couple of applications using this method. Alright, so suppose I have a triangle drawn in a coordinate plane. So I've got 3 points as the endpoints, as the vertices. This one is going to be some x and y value, this is some xy value, and this is some x and y value. We can find the area of a triangle by doing, they put plus or minus, really. I think absolute value would work better here, but then it would be really confusing with the bars. So basically, your area is always positive. So we're taking the positive of whatever we get. 1/2 times the determinant, remember these bars mean determinant, of our coordinates, and we put them x1, y1, and then we put a 1 because there is no z dimension. And then we go x1 or x2, y2, and then we put a 1, and then x3, y3, and we put a 1. And so we're just going to take the determinant of this and then half it, and that will give you the area of the triangle. It's pretty interesting. So let's just try one. Let's find the area of a triangle that has vertices 0, 0, 2, 3, and 4, 0. So I'm going to go positive or negative 1/2. And then the determinant, I'm going to take my x's 0, x1, y1, 0, 0, and then 1. And then the second one, 2, 3, 1. And then the third one, 4, 0, 1. So let's do the determinant of this using the diagonals method. Means I'm going to repeat the first two columns. There's lots of zeros in here, so it's actually going to be really easy. Because we're going to go down 0 plus 0 plus 0, right? Because anytime you multiply by 0, you get 0. And then I'm going to go up. I've got 4 times 3 times 1 is 12, plus 0 plus 0. So if I go 0 minus 12, I get negative 12, only we're going to take the positive value of it, and don't forget, we have to half it. So half of 12 gives us an area of 6 units squared. Just like that. Alright, now there's one other application. We can use a determinant to find the equation of a line. Because if I have 3 points, and if I'm trying to find the area of the triangle, and they're all 3 in a line, then when I make a triangle, I'm not going to have a triangle, and my area would be 0. So to find the equation of a line, if I've just got 2 points, you only need 2, we're going to do this. Alright, so if I have 2 points on my line, AB, and another point, CD, we take 1 point here, AB, and we put the 1, because it's in 1 dimension. We put CD here and put a 1. And then since we're doing the equation of a line and it needs an x and a y in it, you have your x and y, x, y, and 1. And so then we have to set that equal to 0. So we're going to find the determinant, which is going to have an x and a y in it, and we're going to set it equal to 0. Alright, so last example. We're going to use a determinant to find the line through -1, -3, and 4, 7. So yes, you've already learned lots of other ways to find this line, but we're going to now do it the determinant method. I'm going to set it up. -1, -3, 1, 4, 7, 1, and x, y, 1. And I'm going to do my downs first. Oh, I'm sorry. First I'm going to copy my 2 columns. And then I'm going to go down. -1 times 7 times 1 is -7. -3 times 1 times x is -3x. And 1 times 4 times y is plus 4y. So that's my bottoms. Then I have x times 7 times 1 is going to be 7x. Y times 1 times -1 would be -y. And 1 times 4 times -3 would be -12. So I'm going to do Chris minus cross. -7 minus 3x plus 4y minus, put it in parentheses because we have to distribute, 7x minus y minus 12. Sorry, you can't see the 12. And we have to set that equal to 0. So when I do this math, I have -7 and I have minus -12. So that's 7 and 12, which makes 19. Yeah, I lied. -7. It's -7 and a positive 12 because minus times minus is plus, so that gives me 5. And I have -3x minus 7x is minus 10x. And I have 4y minus -y would be plus y, so plus 5y equals 0. And I'm running out of space, so let me scoot this up a bit. Alright, I've got 5 minus 10y plus 5y equals 0, so I want it. It just says find the equation of the line. Let's go ahead and put it in y equals mx plus b, so I'm going to move 10x to the other side and subtract 5 to the other side and divide everything by 5. Y equals 2x minus 1. That is the equation of the line through those 2 points. And that's nifty. I know you guys all think it's super duper exciting. I know you do. Alright, I know this has been a long video, so take a deep breath. You're done. Go do something fun. And I'll see you guys on Monday. Bye.